Dear all, good evening. Let us see the important problem on the spring system. Okay, here the red color indicates the given problem. Determine the displacements of the nodes of the spring system shown in figure. Here 40 Newton per mm, 50 Newton per mm and 80 Newton per mm and 60 Newton force and 50 Newton force and node 1 and node 2 given. Now we are added K1, K2, K3. These are the different stiffness values of the spring system. So here we are taking, let us take delta 1, delta 2, delta 3 as displacements of the springs. So delta 1, delta 2, delta 3. Each spring having some displacement, right? Also we are taken Q1, Q2 are the displacements of the nodes 1 and 2. Here node 1 and 2 we are taking Q1 and Q2 as the displacements. So there are also asking the same displacements of the nodes. Okay, we have the basic formula from the strain energy of K1 delta 1 square. So here there are three springs are there. So K1, K2, K3. So like that K1 delta 1 square, K2 delta 2 square, K3 delta 3 square. Here also some loads are there, F1 and F2. These are acting this direction. So minus F1 Q1 minus F2 Q2. Okay, so here we observe this stiffness and this delta 1 value, those are displacements. These are corresponding to this node 1 and this is also corresponding to this node. So that's why in place of delta 1 we have taken Q1 and here also Q1, but we observe the delta 3, this is in between Q1 and Q2 nodes. Okay, in between Q1 and Q2, that's why in place of delta 3 we have taken Q2 minus Q1. Remaining are same, F1 Q1 minus Ft Q2. Here the basic formula dou phi by dou Q1. So the function phi with respect to Q1. So 1, 2, 3 like that. So let us take dou phi by dou Q1. So you have to differentiate with Q1 about this phi function, right? Strain energy. So with respect to Q1, see, you can see from this equation K1 like x square, 2 into x1, so 2 into Q1 plus 1 by 2 K2, again 2 into Q1. Here see 1 by 2 K3. Here Q2 minus Q1 you have to take it as some x values. So x square, so 2 into x, 2 into this entire value, 2 into this entire value, 2 into some x value. Okay, again in this x value we are with respect to Q1 is there, so minus into 1, so that's why this plus will change it as minus. In place of Q1 you will get minus 1, so minus, then minus F1. So Q1 with respect to Q1 you got minus F1. There is no F1 term. This is equal to 0. You can simplify it. Here 2 to cancel. So K1 Q1. 2 to cancel. K2 Q1 minus K3 Q2 minus Q1 minus F1 0. This is a simplified equation. But from the spring mass system, see where K1, K2, K3, 40, 50, 80, 40, 50, 80, K1, K2, K3. Then F1 is equal to 60 and Ft is equal to 50 newtons. Right? So this is you are updated as in place of K1 we are taken 40, 50 and in place of K3 we are taken 80. So same value. I have shifted to, I have changed into other direction. So I have taken into other direction. This is minus, it will be plus if you go into other side. Is equal to F1 is equal to here 60 newtons. Here Ft is equal to 50 newtons. Let us take this one as equation number 1. Then dou phi by dou Q1, similarly dou phi dou Q2. With respect to Q2 you have to do the same. See here, same function. In this here, there is no Q. Here with respect to Q2, so Q1 term 0. No Q2 term. Here also no Q2 term 0. Here 1 by 2 plus K3 into. So this also you have taken it as some of x square. So 2 into entire value. 2 into Q2 minus Q1. Okay. Again in this we have a Q2 term. With respect to Q2 we have a Q2 but 2 into Q2. So you will 2 into 1. Sorry. This is 1 by 2 plus K3. This is entire x value, 2 into x value. Yeah, again for Q2 we will get 1. So we can divide with, you can multiply with some value 1. Or you can leave it. So in place of Q2 we will get 1. Minus, from this we will get minus F2. Okay. So after simplification, after cancelling 2, you will get K3, Q2 minus Q1 is equal to, in place of minus, you will get the plus F2 is equal to, what is F2 value here? 50 newtons. So this is equation number 2. Here in place of K3, you will take the 80 Newton per mm. So 80 into Q2 minus Q1 is equal to 50. So here Q2 minus Q1 is 50 by 80. You will get 0.625. So this is simplified value, right? Now I want to substitute this value in the equation number 1. In place of Q2 minus Q1, I am substituting the value. Then you will get 40 Q1, 50 Q1 minus 80. In place of Q2 minus Q1, the value is 0.625 is equal to 0. That is F1 value. Sorry, F1 is equal to 60. So after simplification, we got like this. Again 90 Q1. This minus, we send that side, it will be plus. So 60 plus plus 80 into this value, you got 110. So Q1 is equal to 110 by 90, you got 1.22. Now we can substitute this Q1 value in this equation. So Q2 minus Q1 value 1.22. Finally you got the Q2 value. So as per the question, you got Q1 and Q2 values. Okay, thank you.